Good morning, everyone. This is lecture number 3, and in this lecture, we will be studying the laws of heat transfer. Till now, we have seen the basics of conduction and convection. Now, we will be studying the laws that governs the process of conduction and convection in solids and between solids and uh, fluids, respectively. The first law of heat transfer that we will study is Fourier law of conduction. Fourier's law of conduction. For this to study, I would like to draw a slab, rectangular slab. This is a rectangular slab. The left face of the slab is at temperature T1, and the right face of the slab is at temperature T2. The heat flows from left to right, that is in the horizontal direction because of this temperature difference delta T, T1 minus T2. The width of the slab is L. If I consider a very small element of width dx at a distance x from the left face, then for this small element, the horizontal distance covered is dx and temperature drop will be dt. Therefore, the ratio of dt over dx will be called as temperature gradient. Here, temperature gradient will be dt over dx. Now, if I talk about this element, the heat transfer rate for this element, the heat transfer rate in x direction will be directly proportional to the temperature gradient, will be directly proportional to temperature gradient in x direction. The negative sign here shows that the heat flows in the direction of decreasing temperature. That's why the dt term will be negative. Therefore, the final temperature minus the initial temperature will be negative. Therefore, the net value of heat transfer should come out to be positive. That's why this negative sign has been kept. The second thing is the Fourier law also says that the heat transfer that is taking place in the x direction should be directly proportional to the area that is lying perpendicular. That means this area, this is small area, this area of the face. If I draw with a different color, then this red color area is the area that is come in the direction of heat transfer. The heat transfer is taking place perpendicular to this area. The heat transfer will also be proportional to the area of this face. Let's say area is A. So the heat transfer will be proportional to area A also. Clubbing these two, we can get heat transfer in x direction is directly proportional to minus A dt over dx. If I remove the proportionality sign, then it will be minus ka dt over dx, where k is the proportionality constant. K is coming in place of proportionality constant, and here k is nothing but thermal conductivity of slab. Thermal conductivity of slab material. So this is called Fourier law of conduction. Now we can write the definition of Fourier law of conduction with the help of our above understanding from the above example. The law states that the rate of heat transfer by conduction in a given direction is, now the main thing comes, directly proportional to the temperature gradient. Temperature gradient along that direction. And is also proportional also proportional to the area of heat transfer lying perpendicular to the direction of heat transfer. This is the law of the Fourier law of conduction. This is the definition of Fourier law of conduction. This is the definition. Moving on to the term negative sign. Negative sign here indicates that the heat always flows in the direction of decreasing temperature to satisfy the closest statement of second thermodynamics. Here, negative sign indicates indicates the flow of heat in decreasing temperature direction to satisfy the Clausius statement of second law of thermodynamics. Now we are done with the Fourier law of conduction. The second law of we will be studying is Newton's law of cooling, and this is used for convection. Newton's law of cooling. न्यूटन्स लॉ ऑफ कूलिंग कहता है Newton's law of cooling states that the rate of convection heat transfer rate of heat transfer by convection between a solid and surrounding fluid between a solid and a surrounding fluid is directly proportional to the temperature gradient. Sorry, it's directly proportional to the temperature difference. Directly proportional to the temperature difference between them, and also proportional to the area of contact or area of exposure. It says that if there is a plate, horizontal plate at temperature P1, and this is a hot plate, and there is a surrounding fluid which is at temperature T infinity. Then the heat transfer will take place from hot plate to surrounding fluid. Let the area of the plate is A in meter square. Then the law says that the convection heat transfer is directly proportional to the temperature difference. Also, convection heat transfer is directly proportional to area. Therefore, this convection heat transfer is directly proportional to A into delta T. If we remove the proportionality sign, then the constant of proportionality comes HA delta T, and this delta T is nothing but wall temperature minus free stream velocity. Free stream temperature of surrounding fluid. So this is the convection, Newton's law of convection. This is the relation for Newton's law of convection. H is convection heat transfer coefficient of convection heat transfer, or convection heat transfer coefficient. The C unit is watt per meter square Kelvin. Okay, now H is the convection heat transfer coefficient we have seen. Now there is certain H is the constant of proportionality that we came across, that we came to know in convection, Newton's law of convection, and K is the thermal conductivity, or also it was the proportionality constant that we came across in Newton's law of cooling. Fourier's law of conduction. Now, if we talk about K conductivity, conductivity is a property of material. K thermal conductivity is the property of material. This is the thermal conductivity of material. If we talk about the H, which is convection heat transfer coefficient, It is not a property of material. Unlike thermal conductivity K, H is not a property of material, but it depends upon thermophysical properties. Upon thermophysical properties. What are thermophysical properties? Thermophysical properties are those physical properties which are affected by the heat transfer or which affects the heat transfer. Out of those physical properties, this is those properties which affect the heat transfer are thermophysical properties. The example of there are four such properties that we will be studying in heat transfer. The four three thermophysical properties are: first, density. Its unit is kg per meter cube. Second is dynamic viscosity of fluid, Pascal second. This is also density of fluid. Third is the constant pressure specific heat of the fluid. Its unit is joule per kg Kelvin. And fourth one is thermal conductivity K. It is the property of material or thermal conductivity of fluid also. Watt per meter Kelvin. K may be the thermal conductivity of the fluid or thermal conductivity of the surroundings solid surface depending upon the case. These are four thermophysical properties. Physical properties. H depends upon these thermophysical properties. Since H is a convection heat transfer coefficient and convection is a uh, dependent upon whether the convection is caused by force caused forcefully by an external agency or it is a free convection. Therefore, convection heat transfer coefficient will also depend upon the type of convection. If it is a forced convection, if it is a forced convection, in that case, convection heat transfer coefficient will depend upon the velocity of the fluid, characteristic dimension of the surface, density, dynamic viscosity, Cp, and K. These are the six factors on which the uh, convective heat transfer coefficient will depend. D is characteristic dimension. Second one is free convection. In the free convection, convective heat transfer coefficient depends upon a large number of parameters, out of which four are thermophysical properties. We can write H as a function of G, exertion to gravity, beta, Isobaric volume expansion coefficient, delta T, temperature difference, L, characteristic length, mu, dynamic viscosity, rho, density, Cp, specific heat, K, thermal conductivity. Here beta is isobaric volume expansion coefficient. Volume expansion coefficient. Okay, note. Important information is that thermal convective heat transfer coefficient for water is higher than that of air. वाटर का convective heat transfer coefficient air से ज़्यादा होता है. Considering this same kind of convection, if we talk about the forced convection, in that case H water will be higher than the H air. If we talk about the free convection, in that case H water will be higher than the H air. If we say that the convective heat transfer coefficient in free convection and convective heat transfer coefficient of air in forced convection, then there may be a variation. The above relation will not be will not hold good. So till now we have seen the conduction and convection laws, the laws of heat transfer that governs the process of conduction and convection. So that comes to the end of this lecture, lecture number 3. In the next lecture, we will see uh, the application of Fourier law of conduction and Newton's law of cooling. That's the end of our lecture. This lecture number 3. Thank you.